Hey guys, we are doing the 2018 final. We're going to move on to the OLG question, but first, just show you this is a graph of the two steady state conditions for that Ramsey equation. Just to see that based on the parameters, this will have a steady state solution. So over here, H is rho and D is delta. Alpha and beta are correct. And you can see if you put them all as positive values between 0 and 1, it will intersect. And as long as we have a positive point of intersection, then there's going to be a solution to the steady state. And what that solution is will just depend on the value of the different parameters. A here will just make it, the higher your technology, the greater your steady state output. So we have a good steady state and it comes out as we expect. So let's move on to looking at exercise 3, which is an OLG. And it tells us that we're going to have an OLG, but our wrinkle is that there is a probability of 1 minus p that we will have an accident and will be totally unable to work and earn a salary. Instead, we'll get a pension M. And then we have a normal sort of lifetime utility function to calibrate around. And it asks us, number 1, to write the budget constraints of the household taking into consideration the probability of the accident. So for this one, when we're old, nothing is going to change. So let's start with that. When we're old, we always write that as dt plus 1. And that's just going to be equal to our savings from time t. Our savings from time t times 1 plus accumulated interest in t plus 1 minus the rate of depreciation. So that takes care of dt plus 1. That's our first constraint. And then the second constraint is going to be a little bit more complicated. Normally, we just write that our wage that we earn in time t can be split either between consuming in time t or saving in time t. So written otherwise, we can write that Ct is equal to St minus Wt. That what we save, sorry, that's backwards, that consumption is equal to our wage that we earn minus our savings. But here we have a situation, so with a probability 1 minus p, we will have an accident. And instead of getting a wage W, we will get a pension M. And then with probability p, we're able to work and earn a wage W. So we have two possibilities. Our consumption is either going to be probability p that everything's fine and we get our Wt minus St, or with probability 1 minus p, we'll have an accident. And then instead of earning the Wt, we'll earn M, and we'll still have to save for old age. So that's going to be our consumption, or our budget constraint in period 1 when we're young. So let's plug those into our utility. We know that utility is equal to A times the natural log of Ct plus 1 minus A times the natural log of dt. And we only have one first order condition. We're going to maximize this with respect to savings, plugging in our two consumption equations. So we have P Wt minus St plus 1 minus P M minus St plus 1 minus A times the natural log of St1 plus Rt plus 1 minus delta. So that's just the setup, and then in the next video we'll just solve this. I guess I'll throw in that we're going to use just the one first order equation. du over ds is equal to 0. So we'll maximize our savings, and then we'll clear all the markets. Our goals when we do an OLG question are, number 1, maximize savings when young, or I guess over your life. Maximize lifetime savings, given that we value our consumption at young and old times differently based on that A parameter. And then 2, clear the markets. Based on that, we maximize our lifetime savings, finding S star, C star, and D star. And then using those, we can clear the markets for labor and goods. And then finally, the full equilibrium. Okay, so I'll see you in the next video.